Hello everyone, welcome to today's lesson on rate of change. Right, so this is sort of a continuation on the slopes, right? Because rate of change and slopes are pretty much, we can think of it as the same idea. Right? So now let's start with a linear relation. Right, so in a linear relation, there's a constant change between the variables. Right, so every time the variables change, it's always going up by the same amount. So as you can see here, right, at each point in our table, or between the two order pairs, right, the x value is going up by 100 each time, whereas the y value, the cost, is going up by 20 each time. Right, so they don't have to be going up by the same amount, but as long as they're changing by the same amount each time, then we call that a linear relation. And when there is a linear relation, we can then find the rate of change. Right, so the rate of change, in this case is pretty much just the slope with the units tied behind it. Okay, so let's find the slope first. Now we can take any 2 points on the graph. Let's say we can take this one here, which is the x400, y140. And we can take this one here, right? X is 0, y is 60. Okay, realistically, any point will do the trick. Okay, so when we find a slope, we take the change in the y value, right? So it's 140 subtracted by 60. Right, and then 400 minus, oh, sorry, got it other way around. Wait, no, just, no, sorry, I was right. Anyways, next is the x values, 400 minus 0. Right, so this right here is 80 over 400, which can both be reduced, right? They're both divisible by 80. This is reduced to 1 over 5. Okay, and the last step is to include the unit. Right, the unit here, y over x, right? Changing y over changing x. The y value is the cost in dollars. The x value is kilometers distance. So the unit is just dollar per kilometer. Okay, so with rate of change, we always include the units. Okay, so you can also think of it as $0.2 per kilometer. Okay, so 20 cents per kilometer. Okay, and then from there, we can find an equation with it as well, right? So what we covered last lesson. We know the slope is 1 over 5. We just have to find the y-intercept, right? And as we can see right here, right, the y-intercept, where it touches the y-axis, is at 60, or 0, 60. So our equation here is the slope, x plus the intercept, which is 60. Okay, there we go. Okay, and next, let's go the other way around. Right, so now we're gonna be given some information, and then we're going to find a graph. Okay, so between the year 2000 and 2010, a cost of the TV went from 4,600 to 1,200. Okay, so for our first point, so let's say point A here, right? The year 2000, it cost $4,600. Right, and at the year 2010, it's 1,200. Okay, and we know that the years is the x and the price is the y. Right? We know that's the y is because again we think about x as our independent variable and y is our dependent. Right? What value is dependent on what? Is the price of the money dependent on a year, or is the year dependent on the price of the TV? Right? Of course, in this case, we know that because it's the year 2000, the price of the TV is 4,600. And then we know for sure, okay, the money, the value of the TV depends on what year it is. Okay, so that's why we know the year is the x values and the money is the y values instead of the other way around. Right, so that's the independent, and then this is a dependent. Okay, let's find the rate of change or the slope. Okay, so we do the change in the y. So we have this minus this. Okay, we can do the other way around as well. Over this minus this. Right, and we get negative $360 per year. Okay, so remember, watch out for our units here. Okay, so that's our rate of change. I guess we don't actually need to box it. That's not what we're looking for. But that's something it's useful to know. And that's our rate of change. Okay, and of course the units, right? The y values is the price, as the x value is the year. So it's dollar per year. And lastly, we want our equation now. Right, we know the slope is negative 340x. And now I want you to know what the y-intercept is. Okay. This is where it'll be useful for us to start graphing it out. Okay, so we got our lines. You can see LCD TV prices. Okay, so now this time it's a little bit different, right? Because we're starting at different metrics or different values, right? We're not starting at 0 here for the year. We're starting at 2000 and then we're ending at 2010. Let's see, how many spaces are there? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. 11 spaces, okay. Wait, hold on. 1, 2, 3, 4, 5. And then 1, 2, 3, 4, 5. Okay, so I want to kind of make it in the middle. So we actually want 10 spaces here, right? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Because if we do it like this, we can have a 2005 in the middle here. Right? But realistically, you don't really actually need it. Right? We just need 2 points on the graph. Okay, and how about the money? For the money, we start at 0. Okay, and the maximum we can want to go up to is 4,600. Okay, so let's see, how many spaces are there? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay, we got 10 spaces here. So we can just go up by 500 per square, right? Because if we do that, 3,000, 4,000, 5,000. Okay, because if we go up by 2 like this, right, we can then easily fit 4,600 in our graph right here. Okay, so at the year 2000, we have 4,600, so somewhere here-ish. And at the year 2010, we got 1,200. So it's somewhere around here-ish. Right, so now importantly here, we do not put an arrow here because that's the only 2 data points we know. Okay, so that's what the graph looks like. And now we can obviously see, oh yeah, the y-intercept is where we started the data, which is at the year 2000. And so, at the year 2000, the TV cost 4,600. So that's our y-intercept. Just like that. Alright, rate of change. Okay, let's look at this example right here. Right, so as a professional meme maker, Mr. C earns a basic salary of 1,500 with an additional $400 for every viral meme he creates. Okay, so let's start by figuring out what his salary would be for every single meme he creates. Right, so we know that for every 5 memes he creates, he gets $400. Right, which means that if he creates no memes, he gets $0. So the slope of the amount of memes he makes, the slope for the dollar he earns per meme, right, is then changing y subtract by changing x. is 80. Right? And we know that he earns a basic monthly salary of 1,500. So if we put it all together, right, we get this equation right here. Right, so we know that for sure he gets 1,500 to start off with. Right, but for every meme he creates, he will earn 80 bucks, right? Because it's 400 for 5, so it's 80 bucks for one of them. And from there we can figure everything else out, right? How many memes must be made for Mr. C to make at least 3,444 a month? So we want to figure out how many memes to create, which is X. We simply plug that in. Which is 1940 equals to 80x. Divided both by 80. We got 24.25. Right? Or more specifically, he'll need to make 25 memes, right? Because we cannot just make 24.25 memes. We need 25 memes. I don't have whole numbers. Okay. What would be Mr. C's wage if he makes 60 viral memes? So once again, we just plug that in. But this time we plug in the X, right? Because that's the number of memes he makes. Or the viral memes he makes. Plug that all in, we get 6,300. That's pretty nice. Okay, and how about rate of change? Alright, so rate of change is just a slope. Alright, just a slope with the units. So we know it was 80. Alright, that's what we found earlier with the slope. The units here, right, the changing y over changing x. Right, the changing y, right here, is the money. Right? 5 memes for 400 bucks, 0 memes for 0 bucks. So we know our unit is dollars over the changing x. The units for x is we got 0 memes and 5 memes. So it's dollar per meme. That is then our rate of change. $80 per meme. Okay, just like that. Okay, so now let's try to figure out this question now. Right, we are given this graph here. We are tasked with an electrician charged 190 bucks for this job. How many hours did they work? So as you can see here, right, in this graph, we're going up by 60 for each grid. So 190 will be somewhere around here-ish, right? But we don't know exactly where, right? We cannot just we can guesstimate, but we want an exact number here. So first step is we can actually find the equation for this graph, right? Because we know the y-intercept is at 60. And we can take another point here, let's say this point. That's 3 and 180, because it's going by 60 each time. Alright, the y-intercept, 0, 60. And then the slope, right, we have our 2 points here. Right, y minus the y, x minus the x. That's our slope. So now in total, our equation is slope x plus the y-intercept, which is 60. And now our final step is he was charged 190 bucks or a day. So 190 equals to 40x plus 60. We subtract 60 from both sides. Divide both sides by 40 to get us 13 over 4 hours. Right, and that's our answer. Right, so this electrician worked 13 over 4 hours. Or, cumulative mixed numbers, around 3.25 hours. So 3 hours and a quarter. Okay, but that's how we use rate of change, right? Slopes have no meanings. Rate of change is the same number as the slopes, but we give rate of change a unit. so that we know exactly what the slope actually tells us. Right, so that's what rate of change is. But with that being said, that's it for today. So good luck practicing.